in our science book, page 49, we have inventors John Diebold and Martin Culpeper. John Diebold spent much of his life studying Earth's oceans. He worked in the lab and in the field. He studied volcanoes, ancient ice sheets, and faults that caused earthquakes underwater. Dr. Diebold improved the design of the air gun, a tool used to make underwater sound waves. That's pretty cool. And then he used these sound waves to make 3D pictures of the ocean floor. Neat. And then Martin Culpeper. Martin Culpeper is a mechanical engineer. He invents tools that work with machines so small you cannot even see them with a regular light microscope. These machines are many times smaller than the thickness of a human hair. I didn't even know these existed. One day, these tiny machines could be used to find cancer cells. Unlike Dr. Diebold, Dr. Culpeper does most of his research in a lab. His lab has to be dust-free. A tiny bit of dust could ruin the results of his investigations. Neat. All righty. So actually, we are going to have time to do lesson 5 because lesson 4 was super short. So lesson 5 seems to be like a more normal lesson that we've been used to. So we're going to go ahead and skip to lesson 5 on page 51. What kinds of models do scientists use? And we see the lesson vocabulary that we will write at the bottom. Models and science. Native Americans had mental models for the sun, moon, and planets. Several tribes in North America tell stories of the beginning of time when Earth did not exist. All of the animals applied mud to the shell of a turtle. Earth was born when the mud became thick and large on the turtle's back. So that's just how they believed that the Earth was formed. There's an ancient kind of interpretation of what this kind of meeting looked like, and this is what kind of they thought happened. So let's skip this drawing that you could do. You can certainly do it of a model. Actually, it's a floor plan of your room and your home. Show the doorways and windows. Show objects that sit on the floor. Add labels. Be accurate. That is something you can do in your own time. A toy car, a doll's house, a person who shows off clothes on a runway. These are all models, but what is a model in science? Scientists make models to represent the natural world. In science, a model represents something real that is too big, too small, too far away, or has too many parts to investigate directly. For example, our solar system is too big to see all of its parts at once. So scientists use models to investigate the motion of planets, moons, and other solar system objects. They can use the models to predict when an asteroid will pass close to Earth. So let's go ahead and go back one page and write down the word model under lesson vocabulary. Model. M-O-D-E-L. Models can take many forms. A mental model is a picture that you make in your mind. A good thing about this kind of model is that you always have it with you. A two-dimensional model has length and width. It can be a drawing, diagram, or map. So I go back. I'm going to shorten that to 2D. We've probably seen that before. 2D represents two-dimensional. If it said 3D, that means three-dimensional. 2D model. 2D model. Models do have limitations, including accuracy and size. Our solar system is so large, an accurate model would also need to be large so that it includes enough detail. Other models scientists use. let's go ahead and do the math with fractions today. I know my fourth graders, we haven't gotten to much fractions yet, but let's see what we can do. You plan to make a model of the solar system. You make the tiniest ball of clay you can for Mercury. The ball is 4 millimeters across. If Mercury were that size, the chart shows how big the other planets in your model would be. Which fraction tells how the size of Mars compares to Earth? So if we look at Mercury, is 4 millimeters, and we're talking about Earth. How does Earth is 10? If you are off, stay on mute, okay? Which fraction tells how the size of Mars compares to Earth? Mars is 5, so Earth is 10. What fraction would tell us the size of comparison of Mars to Earth? Olive?
6.
It has to, we have to have a numerator and denominator. William, I saw your hand.
It is 1/2.
We're gonna flip that. Well, Mars compares to Earth. Yes, that is, I was thinking Earth to Mars, but yes, 1/2. Mars is 1/2 the size of Earth. Which object is about 1/4 the diameter of Neptune? Neptune is 36. Think of 1/4. So basically I am dividing 36 by 4. Which one tells me the answer? What do you think? Hank, what do you think?
Venus.
Venus is our answer. Which object is 1/9 the diameter of Saturn? Saturn is 92, and we are dividing by 9. What is about the size, 1/9 the size of Saturn? It's not going, like if I actually divided this, it would be a remainder. Which one is close? Olive?
1/2.
I'm looking not for a number, but a name. So again, let's look at Saturn.
Sorry.
No, you're fine. Saturn is 92. I'm dividing 92 by 9. What is the closest answer? The 92 divided by 9. William, I mean not William, Charlotte. Gotta raise your hand if you want to share your answer. Charlotte, sorry.
It is like are you looking for a name of a planet? Is that
Yeah.
it? Okay. Neptune?
No. Somebody who knows it, you got to raise your hand. You got to come on camera. I can't be checking back and forth with chat or anything else. Lucas, you want to try?
Earth.
Earth. Earth. If I divide 92 by 9, I'm looking for an answer that is close to 10. Earth is the closest to 10. Well, it is 10. All right. You see the thousands of stars in the night sky. I'm on page 55. You point to a very bright star. Suddenly, you are zooming through space. As you get closer, the star gets bigger and brighter. Your trip isn't real. but it feels like it is. It's another kind of model. Three-dimensional models. The more a model is like the real thing, the better it is. If the object you want to model has length, width, and height, it is a three-dimensional model and it is useful. Such a model can show the positions of planets, moons, and the sun better than a two-dimensional model can. If you want to compare sizes and distances in a model, then you make a scale model. Scale model. I know that that is not highlighted, but when it's to scale, that means all the planets are showing that one is smaller than the other and then one is bigger. They're not all the same size. The scale model tells how much smaller or bigger the model is than the real thing. For example, a model railroad may have a scale of 1 to 48. This means for every 1 inch on the model stands for 48 inches on the real train. Computer models. What if you want to understand how asteroids move through the solar system? You'd use a computer model. A computer model is a computer program that models an event or an object. Some computer models make you feel like you are moving through the solar system. Oh, let's go back to page, I'm sorry, all the way back and put computer model, 3D model, and scale model. I put all three on page 51. I put all three on page 51. All righty. I'm going to go ahead and change to weather models. Save lives. On page 56, dangerous weather can happen suddenly. Hurricanes, tornadoes, floods, and winter storms can harm people, pets, and homes. How can models save lives? Data from space. Satellites circle Earth 24 hours each day. Images and other weather data are beamed back to Earth. It's called real-time data because scientists see the pictures almost as soon as they are taken. This image shows the path of a hurricane. The colors are not real. Scientists choose them to show differences in wind speeds, heights of clouds, and other factors. Using models, meteorologists use satellite data to make computer models of weather. They model hurricanes, tornadoes, and thunderstorms. The models are used to predict how and where storms will get started. Getting the word out. Weather reporters also use models. They make two-dimensional maps for television and internet viewers to see. These maps can change to show how soon and how bad weather will be. Let's skip this thing about the family and let's go ahead and try to do, I like the brain check on page 59. It is a crossword, and in this crossword, you're going to use the word bank on the right to fill in your answers. I'm going to give you guys about 5 minutes to see if you can fill in the crossword on page 59. on our crossword. I already see one answer that I know. 2 across, the type of model that is in your head. Lucas,
Mental model.
mental model. MENTALMODEL. Gotta spell it correctly or else it won't fit. What is another answer that you know? Something that represents the real thing. That is 4 across. Owen,
Model.
model. I can mental model. These kinds of models can save lives. This is 6 across. Weather, Charlotte, I'm kind of giving the answer away. Sorry.
6 down.
Across.
6 across. Okay. 1 second.
7 letters.
Weather.
Weather. A type of model that has a length and width. Length and width. Kira?
2-dimensional model.
2-dimensional. Now, I don't know if I have to include the dash. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19. No, no dash. 2-dimensional. D-I-M-E-N. Unless I counted that incorrectly. Dimensional. M-O-D-E-L. Perfect. 2-dimensional model. A device that sends weather images back to Earth. William, do you have that one?
Satellite.
Satellite. S-A-T. Gotta move my thing up a little bite. S-A-T-E-L-L-I-T-E. Satellite. Down. 1, a type of model made with a computer program. Owen.
Computer model.
Computer model. A type of model that has length, width, and height. Carter, I haven't heard from you yet.
Oh, can I do number 8 real quick?
I will ask you 8 after when we get to 8.
Okay.
Olive.
3-dimensional model.
3-dimensional model. T-H-R-E-E-D-I-M-E-N-S-I-O-N. 3-dimensional. N-A-L-M-O-D-E-L. Longest word I think I've ever seen in a crossword. 5 down. In this type of model, a measurement on the model stands for a measurement on the real thing. Kira?
Real time.
What was that? Oh, real time? Yeah. 5 down. Actually, that one's not going to work there. 5 down needs to be scale model, because that will fit. Carter, what is 8? I know you wanted to do 8.
Real time.
Real time. It's got to fit in the boxes. All right, well, that actually brings us to the end of our science today. You guys are not going to have to take a picture of this today. I will upload the video. When I get the uploaded video, can you just turn it in to tell me that you were here for Zoom for science, and I will give you credit for that. Yes, Hank, and I will, we're going to switch over to math. So I'm going to put my math book, my simple solutions under my ladybug. And if you are just joining us in Zoom, I did put the Google Classroom in the chat box. If you click on that link, it will take you to Google Classroom. Okay. We're going to switch over though to simple solutions.